Hey everyone, in this video we are going to go over the first project for my course, Virtual, Augmented and Mixed Reality, which I'm currently taking at UIC. This project is an augmented reality application that involves displaying certain widgets that show useful information to the user. The widgets are displayed over image targets from the Vuforia Mars database and show different kinds of information like date, time, and weather. To run this project, you need the Unity editor and the Vuforia SDK. The Vuforia SDK is an engine to build augmented reality apps on Windows. You also need a webcam and the image targets from the Vuforia Mars database. The version numbers for Unity and Vuforia are given in the description below, along with a list of image targets that are needed to be printed. Once you have these components installed, you can clone the project from the GitHub link I've posted in the description below and open it in Unity. As mentioned before, the widgets display information like date, time, and weather. The weather information is received using periodic calls to the Open Weather Map API, which requires you to have an API key. Once you have opened the project in Unity, find the request handler game object in the scene hierarchy and enter your API key in the field named API key. Save the scene and then hit the play button to run the application. The date and the time widgets display the date and the time every 30 seconds over the astronaut and the drone image markers respectively. This information is retrieved from the system that the application is being run on. The user also has the option to press the U key to change between imperial and metric formats of date and time. Since the information is updated every 30 seconds, you need to wait at least that long before you want to observe the change in the format. The temperature and the humidity widgets are displayed over the Fissure image marker. The temperature is represented by a thermometer-like model with a level of mercury dependent on the current temperature. Humidity is represented by a beaker which is filled with water depending on the percentage of humidity in the air. The level of the fluids in both of these models change based on the quantities that they represent. The thermometer can also switch between Fahrenheit and Celsius by pressing the U key. Since the weather data is also retrieved every 30 seconds, users need to wait for the change to reflect. The wind speed and the direction widget, which is displayed over the oxygen image marker, is represented by a flag post. The height of the flag on the post changes depending on the current wind speed. The flag is initially pointed towards the top of the image marker to signify north and then changes its direction relative to the top. For accurate orientation, the user is hence advised to lay the image marker with the top pointing towards the north. The unit for the wind speed changes between miles per hour and meters per second based on the press of the U key. The weather condition displayed over the Mars box image marker is the most fun of the lot. There are 9 different weather conditions listed in Open Weather Map and they each have their own models. Some of the models are animated using particle systems to achieve effects like rain, snow, and fog. The user can additionally press the space key after the current weather condition has been initialized to toggle through all the available weather conditions. However, this action will lose track of the current weather condition. Each of the weather conditions also has a unique looping sound effect that decreases as the user moves away from the model. To give a brief overview of the system design, the project contains one game object to handle the API call to receive the weather data. All the widgets use this game object as a shared resource to display their respective data. The application is able to simultaneously track all the 5 image markers and initialize the respective widgets, although sometimes the poor quality of my phone's camera gets in the way. When the camera loses track, the widgets also disappear because extended tracking is disabled. Even though imperial to metric conversion was to be handled through a virtual button, I could not consistently detect the key press of that button, which ended up in having to do away with the button altogether. So that's it for now. Thank you for watching and have a good one.